Lesson 4.2, Video 1, Dividing Monomials. So before we start this, we should remember that when we are multiplying monomials, we would use what we called the product rule. This is for when we multiply monomials. And that says that when we are multiplying monomials, we will add exponents. Well, now we're going to talk about division, or dividing by monomials, which has what's called the quotient rule. And when we are dividing two monomials that have the same base, so the same letter, we are going to subtract the exponents. Now, if we look at our example here, we have a subtraction, and subtraction order matters, so it has to be the first one minus the second one, or if we look at it this way, the top minus the bottom. Okay, and the order matters, so you have to remember that. Again, x cannot be 0. Now right here we have longhand. If you remember, we talked about that. You can do this by writing them all out and then canceling. So if you see what they did here, they canceled one on the top, one on the bottom, another one on the top, one on the bottom, and they're left with 4 times 4 times 4, which is 4 cubed. Or you can use the shortcut which is just taking the top number of 4s, which is 5 of them, the top exponent, and subtracting the bottom exponent, and you get cubed. We'll come and do plenty of examples like that. The zero rule tells us that if we have any non-zero base raised to the power of 0, it's always equal to 1. So x to the 0 is 1. Okay, so for example, 2 to the 0 is equal to 1. 5 to the 0 is equal to 1. A negative number to the 0 is 1. The only thing we can't do is that. We cannot take 0 to the 0 power because x cannot be 0. The base cannot be 0. So that's a nice little thing, because if you keep that in your mind, then you have kind of a little shortcut there if you ever see that it's happening. A bigger, newer topic is negative exponents. Negative exponents are when you have, or are telling you that you have something in the wrong position. Now you can read the definition here, but the way I like to look at it is that when you have a negative power, when you have a fraction, you have a numerator and a denominator. And right now, 4 to the negative 2 power is over 1. And what it does is, the way I think of it, is the negative exponent with that negative says no. You cannot stay here. Okay, no, you cannot stay here. So what happens then is that number with that power gets moved to the bottom. And this is why it's in the denominator. So when you take a number to a negative power, what it's telling you basically is that when you calculate it, you get decimals. Well, the reason you get decimals is because it actually is a fraction. And then when you actually do 4 squared, you get 16, so 1 over 16. And those are good ones, and we're going to talk about those too. But it can go either way as well. I could have very easily had 1 over 4 to the negative 2. And again, this is telling you no, you may not stay in the denominator, you must move to the numerator, and then the power changes. Now notice that the 4 itself did not change signs, only the exponent changes signs. So when you move from a numerator to a denominator position, or vice versa, the exponent is what changes signs, not the number itself out front, or the base. And then this would be, of course, 16. This ends lesson 4.2, video 1.